That H can't be used that way. So that H is done very specifically, very specific purpose. What it does, HL plus HL means what? If in X, if you add X plus A, what it is? 2X. So that H is used to double the partial product. In the initial stage, HL is 0. So that H you may find why it is being done. But you notice that there is a back label also. So in the first code, that H will not do anything. It's redundant because HL is 0. But the next time it comes, it does it. So now, what is HL pair after this RAL first time? What will be the contents of HL after this is done, when I come to decrement B? What will be the contents of HL when I come to decrement B? HL was containing initially 0. So when I come to decrement B, I may come by skipping or I may come by executing that. So can I write by a simple formula which will be correct in both cases? When just before decrement B instruction gets executed, when I come to decrement B, I may come by doing that D, or I may come by skipping that D. So when I come to decrement B, the contents of HL are, do you agree that contents of HL will be 0 if D7 is 0, and contents of HL will be M if D7 is 1? Because if that D is done, what D contains? D contains M. So that D will be executed if D7 of the multiplier is 1. So can I say that HL contains M D7? Agree or not? When program comes to decrement B, HL contains M D7. Means if D7 is 0, it will be 0. If D7 is 1, it will be M. So M D7. So decrement B, jump on nodes is not 0 now. B now will become 7. It will go back. So it goes to that H. So what it will be after that H is done? After that H, the contents of HL will be 2MD7. Right? Then again RL, JNC skip, that D decrement. So when it comes to decrement B, what will be contains? 2MD7 plus MD6 of the original accumulator, of the multiplier, right? D7 goes to carry, but current D7 is old D6. 2MD7. So when 2MD7 plus MD6, again it goes back. So again it will become 2 into this plus MD5. So each time it will be multiplied twice and it will continue till B becomes 0. So at the end it would be 2 raised to 7 MD7 plus 2 raised to 6 MD6 plus up to MD0. That's the answer. That is my multiplication. Is it okay? And then store and result at 8002 and halt. Is it right? Now here, whether that previous problem of multiplier being 0 will come. If multiplier is 0, do you need to check that? Means whether here this is required and initiate A, jump on 0, jump on 0 here. Is it required? Yes or no? It's not required. Even if you put it, it may be okay. But even if you don't put, there is no problem. Then whether to put or not to put. Because even if it is zero, all times carry will not come. So it will be every times that B will be every time skipped. So answer will not be wrong. If you put this, this entire thing will be saved. This entire thing will be saved. Now we have to take a decision based on what? Means even if you don't put, answer will not be wrong. In previous case, the answer was wrong. In this case, even if you don't put or if you put, answer will be same and correct. If you put, if it is really zero, this will be saved. But each time, even when it is not zero, it will be checked again. So 2 instructions will be added and always, and 1, 2, 3, 4, 5, 6. In that case, LXI H00 should have been, if you want to use that, in that case LXI H00 should have been earlier. LXI, so that is reflected. But then 1, 2, 3, 4, 5, 6 into 8, because 8 times it gets executed. So 48 instructions would be saved if it is 0 and 2 instructions are added. Now this would be done always and this would be saved if it is 0. Probability of it being 0 is 1 upon 256. This is a permanent overhead of 2 to save 48 instructions in some likelihood. So that likelihood is less. So it is 256 into 2 you are adding, that is 512 times means, whereas saving is only of 48 instructions. So unnecessary means what will happen effectively, this will make the program slow effectively. I don't know whether you understood or not, but I hope that you may not have understood. If you watch it again, you may understand. Let us stop now.